Hello, I'm Brad Penrose, and this is an introduction to industrial hygiene. In this video, I will describe what industrial hygiene is and how it's practiced. Industrial hygiene is the science and practice related to the anticipation, recognition, evaluation, and control of environmental hazards. These hazards can cause varying levels of health effects, from mild irritation to severe long-term prognosis. Like general safety practice, industrial hygiene follows a formula known as the hierarchy of controls. The hierarchy of controls is a systematic approach to minimizing exposures. At the top of this inverted pyramid, we have elimination and substitution. These are the most effective means of controlling a hazard, as they remove it entirely. While this is ideal, it's not always possible, leading us to the next tier of our pyramid, engineering controls. While engineering controls may not eliminate the hazard, they will physically prevent or minimize exposure to a hazard. Local ventilation is an example of an engineering control. Dust or fumes may still be present, but effective local ventilation can greatly reduce any exposures to personnel. Engineering controls are an excellent way to minimize hazards, but may not always be practical or enough to sufficiently reduce exposure. The next tier of our pyramid is administrative controls or work practices. Administrative controls and work practices include things like shift rotation. Shift rotation reduces the amount of time and therefore the amount of exposure to harmful hazards. The lowest tier of our pyramid is personal protective equipment, PPE. This is the last line of defense and should only be used to further minimize hazards after other solutions have been exhausted. What type of hazards is industrial hygiene trying to control? First, let's broadly describe the two types of exposure. With acute exposures, symptoms will generally result after a single event. In chronic exposures, symptoms occur after repeated events, sometimes days, months, or even years later. In both of these scenarios, effects can range from mild to severe. Gases are low-density particles that rapidly diffuse. Chlorine is one example of a highly toxic gas. Vapors are liquids with a high vapor pressure. A good example of this would be gasoline. It's not the liquid gas that's flammable, but the vapors floating above it. Dust are solid particles. They are generated when handling powdered materials or pulverizing larger solids. One notable example of dust is respirable crystalline silica. Long-term exposure to this type of dust can lead to a serious lung condition known as silicosis. Fumes are vaporized solids that have recondensed. Metal particles that have become airborne during welding fit this classification. Mists are liquid droplets that have become aerosols. Fibers include particles with a 3-to-1 length to width ratio. The most commonly known occupational hazard associated with fibers is asbestos. Inhalation of airborne contaminants. Absorption or penetration through the skin, ingestion by eating or drinking, injection. While the most unlikely, injection of substances directly into the body will be very harmful. Sampling for hazards is usually done on an individual worker to assess the specific risks of their job. However, if a hazard is localized and multiple people are exposed, it sometimes makes more sense to perform an area sample. After gathering samples, results are compared to established standards. In the United States, the relevant standards come from OSHA, the Occupational Safety and Health Administration, NIOSH, the National Institute for Occupational Safety and Health, and ACGIH, the American Council of Government Industrial Hygienists. The legally enforceable levels come from OSHA and are centered on 2 thresholds. At the action level, a company needs to develop a written exposure control plan and perform routine monitoring of conditions. For certain hazards, this can require medical evaluations for personnel. The permissible exposure limit is the maximum substance concentration a worker can be exposed to by law. While NIOSH and ACGIH are not legally enforceable standards, they are generally more stringent, requiring a greater level of protection to the worker. Physical hazards include noise, vibration, radiation, extreme temperatures, and extreme pressure. Noise exposures also follow a TWA threshold. The action level for noise is 85 decibels on an A-weighted scale. If a worker is exposed to just 1 day above a time-weighted average of 85 dB, it is a requirement that they be included in a hearing conservation program. The permissible exposure limit for noise is 90 decibels. At this level, an employer must meet all the requirements of a hearing conservation program and make efforts to reduce exposure as much as feasible. Ergonomics hazards place an unnecessary burden on the soft tissues of the body and are the result of poor workstation design. Excessive reaching, twisting, slouching, and lifting can all cause ergonomic issues over time. Fitting the task by analyzing and adjusting the workstation to the worker can help minimize this type of hazard. Biological hazards include mold, yeast, fungi, bacteria, viruses, and other potentially infectious material. One prominent example of biological hazards is blood-borne pathogens. Any employee reasonably anticipated to have exposure to blood or other potentially infectious materials are required to be trained as outlined in a written exposure control plan. This has been an introduction to industrial hygiene. For more information on how industrial hygiene can help your facility, please visit phconsultation.com. A link is in the description below. Thanks for watching.